Hey folks! So today we're actually going to work on translations and dilations like you read about in your chapter yesterday. You might be getting flashbacks to geometry, which is great because you should be getting flashbacks to a wonderful course taught by a wonderful individual, either Mr. Magua here or myself. Now, we're going to work through an exploration. If you want, I've put the exploration in our Google Classroom. You can have it as a PDF uploaded just so you can take a look at it. If you want, you can also just watch the video on it. As the video goes, you're going to have chances to answer 4 questions. And then there's a 5th one at the bottom of your Google Doc. You're going to answer all 4 of these questions in the Google Doc, as well as the 5th one. That'll count as your classwork grade for the day. You can always, of course, go back to Live Gallagher and ask him what's going on. But for right now, Digital Gallagher time. So let's start with this one. F is given by this dashed line segment here. And we're trying to find g of x, which is f of x plus 3. So if I plug in any x value into g of x, I take whatever f of x spits out and I add that 3. Let's take a look and see what happens. So f of x is equal to 2 here. So that means that g of x is equal to 2 plus 3, so 5. This is equal to 3 plus 3, so 6. 1 plus 3, so 4. Negative 2 plus 3, so 1. 0 plus 3, 3, 1 plus 3, 4. Now I can graph this out. I'm going to use the exact same x values here. I'm going to combine them with these values for g of x to make points. For instance, the first point that I'm going to make is going to be negative 2, 5. Second one, negative 1, 6. And I'm just going to plot them out. 0, 4, 1, 1, 2, 3, and then 3, 4. Connect them. And we get something that looks a lot like our original function, but in a slightly different place. Your job now is to answer this in our Google Doc. Go for it. Cool, so you answered that first one. Let's take a look at the second one. We have a very, very similar idea going on here. The difference is, instead of us adding outside the argument of the function, we're adding inside of it. So whatever f of x is, g of x, we're subtracting inside the parentheses first. So let's find it out. For this one, I'm going to use, this first one, I'm going to use the 1. I'm going to plug it in for x, and I'm going to find f of some number. Then I'm going to use this graph to find out what f of that number is. So this is going to be f of 1 minus 3. That's f of negative 2. Well, f of negative 2, I go to negative 2, I go up to the point, that's equal to positive 2. Let's do the next one. I have f of 2 minus 3. That's f of negative 1. If I go over to negative 1, up to here, that's 3. And I'm just going to do that for all of them. So I've graphed them all out. Now I'm going to erase this a little bit to make it clearer, and I'm going to plot the points. How I'm going to go about plotting them is, I'll use this as my x, and this is my y, so that'll be the point 1, 2. I'll have another point here, 2, 3, 3, 1, so on and so forth. I'm going to plot it out in red. Well, that looks really familiar. Your goal now is to say why it looks familiar. Let's take a look at this next one. Now, instead of adding or subtracting here, we're going to use the values of f of x in problem 1 to make a table of the values of a new function given here. We're multiplying f of x now. G of x is twice whatever f of x is. So, for instance, g of x is equal to -1. That means it's 2 times f of -1. Well, f of -1 is 3, so it's 2 times that. We're going to see what happens. So this is going to be 2 times f of -2. F of -2 here is 2. So it's 2 times 2, so it's equal to 4. Let's do it for the next one. That's 2 f of -1. F of -1 is 3, so that's equal to 6. 2 f of 0 equals 2 times f of 0 is 1, so it equals 2. And we're just going to complete this for the rest. Okay, now we can graph these out as well. Same way that we did before, we're going to have all of these x values combined with these new y values to make points. So for instance, in the first one, I'd use -2, 4. In the second one, I do -1, 6. Let's plot out the rest. Cool. Now, this is called a vertical dilation by a factor of 2. You're going to give the meaning of a vertical dilation and explain how it differs from a vertical translation in that Google Doc. All right, last one. We're going to still use those same values of f of x to make a table of the new values of this image function. Now this one, we're multiplying by a half inside the parentheses of f of x. So, if we were looking at this example, g of -2 is in here, you plug in a -2, you multiply it by a half. Whatever is in this area of the function is right here. You perform what's inside the parentheses and get your -1. And f of -1 is 3. So let's do it for one of these. This means we're going to have f of 1/2 times -4. That's f of -2. F of -2 here is +2. This is going to be f 1/2 times -2. That's f of -1. That's equal to 3. This is going to be f of 1/2 times 0. And that's always nice, because that's just f of 0. That's equal to 1. So on and so forth. Let's do it. Same as the rest of them. These are our x values. These are our new y values. So we're going to use them, and we're going to plot it out in red. my first one is going to be -4, -2. My second is going to be -2, +3. Let's do it. Now, this is called a horizontal dilation. You're going to answer in the Google Doc by what factor is the graph dilated, and how is that factor related to the 1/2 in f of 1/2 x. You're going to answer that in that Google Doc. Go for it. All right. So by this point, you've answered those questions in the Google Doc, all 5 of them, and you're good to go. Now, you're going to give that homework a shot. Remember, just keep in mind what we had here, the little discoveries. And if you want to check to see if your discoveries are right, check back with Live Gallagher back in the Zoom call. Have a great day, folks.